This is the video for accelerated geometry on section 7-2 on two-way tables. Key vocabulary is joint relative frequency, marginal relative frequency, and conditional relative frequency. The essential question is, how do you construct and interpret two-way frequency tables? And then how do you use two-way tables to find probability? A two-way table is a useful way to organize data so that can be categorized into two variables. Suppose you ask 20 children and adults whether they like broccoli. The table shows one way to arrange the data. So as you can see, out of the 20, 3 children said yes, 8 children said no. 7 adults said yes, and 2 adults said no. The joint relative frequency are the values in each category divided by the total number of values, shown in the shaded cells in the table. Each value is divided by 20, the total number of individuals. So what we would do in order to find the joint relative frequency is, for example, the children that said yes, there were 3 out of the 20. So 3 divided by 20 is 0.15. For the adults that said yes, that's 7 out of 20, which is 0.35. And for the children that said no, 8 out of 20 is zero point 0.4 and 2 out of 20 is 0.1. So that's how we find the joint relative frequencies. The marginal relative frequencies are found by adding the joint relative frequencies in each row and each column. So 0.15 plus 0.4 is 0.55, 0.35 plus 0.1 is 0.45, 0.15 plus 0.35 is 0.5, 0.4 plus 0.4 is 0.5. And if you notice, the column total is 1 and the row total is 1. That should always happen if you did this correctly. To find conditional relative frequency, you're going to divide the joint relative frequency by the marginal relative frequency. Conditional relative frequencies can be used to find conditional probabilities, and this will make more sense to you when we work an example in just a second. Example 1 says the table shows the results of randomly selected car insurance quotes for 125 cars made by an insurance company in 1 week. Make a table of the joint and marginal relative frequencies. So I'm going to start off. I know there's 125 cars because it tells me in the problem. If it didn't tell me in the problem, then what I would do is add up all of these numbers to get the total number of cars, or the total number for the table. So for the 0 accidents of a teen, you would have 15 out of 125, which comes out to equal 0.12. 0 accidents for adults is 53 out of 125, which is 0.424. If I add these two up to get the total for that row, we would have 0.544. For 1 accident of a teen, 4 divided by 125 is 0.032. 32 out of 125 is 0.256. And if I add these up, I get 0.288. For 2 plus accidents for a teen, 9 divided by 125 would come out to be 0.072. For adults, 12 divided by 125 would be 0.096. If I add these two up for this row total, I get 0.168. 0.12 plus 0.032 plus 0.072 would equal 0.224. 0.424 plus 0.256 plus 0.096 would give me 0.776. 0.224 plus 0.776 is 1, and 0.544 plus 0.288 plus 0.6168 is 1. Second example says that the table shows the number of books sold at a library sale. Make a table of the joint and marginal relative frequency. So in this example, you're not told up front the total. So what you need to do is take 28 plus 52 plus 94 plus 36 and find out that your total is equal to 210. Now, what I want you to do from here is to pause the video and finish making your table of your joint and marginal relative frequencies. So how did you do? Did you get the same numbers that I have in the chart? 28 divided by 210 is 0.133. 52 out of 210 is 0.248. Add these together, you get the 0.381. 94 out of 210 is 0.448. 36 out of 210 is 0.171. And add these together, you get 0.619. 0.381 plus 0.619 equals 1. 0.133 plus 0.448 equals 0.581. 0.248 plus 0.171 is 0.419. Add these two together, you also get 1. Next example says that a reporter asked 150 voters if they plan to vote in favor of a new library and a new arena. The table shows the results. So part A says to make a table of joint and marginal frequencies. Again, I want you to pause the video and do this for yourself. So you should have the following numbers in your tables for part A. Then it says on part B, if you're given that a voter plans to vote no for the new library, what is the probability that the voter plans to say no to the new arena? So this is a conditional relative frequency question. So I know that they're planning on voting no for the library. So that means I'm only looking at this column now. I know for sure that they're voting because I'm given that they vote no to the library. So that automatically tells you that your bottom number on your probability is going to be 0.48. Then it says, what is the probability the voter also plans to vote no for the new arena? So on the arena side, the no column, and we find that box, would be the 0.28. Divide that out, and you will end up with 0.583, or 58.3%. A company sells items in a store, online, and through a catalog. A manager recorded whether or not the 50 sales made one day were paid with a gift card. Use conditional probabilities to determine for which method a customer is most likely to pay with a gift card. So I've already gone ahead and given you the joint and marginal relative frequencies below. So what we're going to have to do is to figure out whether by store, online, or on the catalog, a customer is more likely to use the gift card, which means you have 3 different conditional probabilities that we're going to find here. The first one that we're going to find is the probability that we use a gift card given that we went in store. So I know I'm in store, which means now I'm looking at this total as my bottom number because I know that I had to be in store. And then out of this row, the gift card number is the 0.12. So if I divide that out, I get 0.4. Next, we're going to find the probability of using a gift card given that I buy online. So now I'm only looking at this row because I can't use the store and I can't use the catalog. I know for sure that it was bought online. So now my bottom number is 0.44 and the gift card number is 0.18. if I divide that out, I get 0.409. One last one. What is the probability that I use a gift card given that I use the catalog? So now I'm restricted to this row. My bottom number is 0.26 and the gift card number is 0.1, which would come out to be 0.385. So if we look at our overall probabilities here, you can see that the online one has the higher probability. So my answer is that they are most likely to use a gift card when buying online.